Now, we're going to go at the next topic now. So, what we're going to look at now is the reason we were doing proper and improper partial fractions. Mainly so we can integrate them. So let's have a look at an example. So for example, what? Yeah, as I was saying, I can't because I've already given 4 hours for this topic of partial fractions. I have to move forward now at some point. But just keep note of them because, if I find like I have extra time for whatever reason, we can do it in that class, okay? So please remember your question. Minus 12 over 3x squared plus 8x plus 4 dx. So you can take out your calculators, and now we have to look at this as a problem. What are the two factors here? What are the two factors? Minus 2 over 3 and minus 2. So plus 2 then. Now, we have done plenty of these now. We've spent a lot of time on them, so let's go through it. First, we multiply cross by the denominator, and I'll get this. Then what I do is I say, let x equal minus 2. Therefore, what the heck? Here, plus here. B. Let x equal minus 2. So I'll get here minus 6 plus 2 is minus 4. So a must equal 3. Let x equal minus 2 over 3. So minus 2 over 3 plus 2 is 4 over 3. So 12 divided by 4 over 3 is 8. Minus 8? Is that right? Look, you're the ones with the calculators, not me. Is b equal to minus 8? Hang on, MB. I'm figuring it out myself.
No, I mean, when you put x equal to...
Hold on, MB. Sorry, minus 9, not minus 8. What's wrong?
A is minus 9, b is 3.
Do I have it backwards? Is that what you're saying? Yeah, okay. This should be B and this should be A, because this cancels the A. Alright, now that we got our A and our B, we can go back to the question. And we get 12 over 3x squared plus 8x plus 4 equals what? Oh, minus 12, thank you. A over 3x plus 2 plus b over x plus 2. But remember, you want to integrate this. So what you have managed to do is change this big problem yes, big problem into small problems, that's right. Those two smaller problems you now have, you've seen in the worksheet on integration of simple rational functions. So who recalls how we go through these now? So I'll break it up into two smaller problems to deal with. So the first one was this. Well, sorry, I mean, this actually is a formula in the formula book, but I'll just go through the process anyways. Not quite, it's not called chain rule. You say let u equal 3x plus 2. And here you let u equal x plus 2. Now, yes, I've skipped a couple of steps because you have done the lesson on substitution method. What do you do first? You calculate the u dx. Then what do you do after that? You find dx. Then what do you do? Substitute it in. After doing those steps, you'll be left with this. Over here, you'll be left with this. So what is the antiderivative of 1 over u? Yeah, 1 over, sorry, my mistake here. I forgot my -9 here in front. You can take that out in front, and here you can take that out in front. So there's actually a 3 here as well. Okay, so you have -9 over 3, and then you're right, this is log u, which is 3x plus 2. And here, this is 3 log u, which is x plus 2. Plus c. I can clean this up a good bit actually, because what's 9 over 3? 3. And then what can I do with numbers in front of logs? To the power. And this one goes to the power. And then what happens when I subtract logs? Divide. This is the second rule of logs from semester 1. So you get log 3x plus 2 cubed over, yes, x plus 2, do I have that backwards? I do actually, sorry. X plus 2 cubed over 3x plus 2 cubed plus c. That's the answer. Yeah, well, this minus here means it's like log A minus log B. It's like that rule. So that's why this one goes down below, because it's the minusing one. Yeah?
Can I just put a big bracket?
Yeah, that's what I was going to do next. So you can change this if you want. Answer equals log, big brackets, x plus 2 over 3x plus 2 cubed plus c. And in fact, I don't want to go over the top here. I mean, Andy, listen, you could have stopped here, you could have stopped here, you could have stopped here. These are all fine places to stop. But if you're looking for maximum simplification, you could even write it like this. A log, no, forget it. I was going to put the A in here, but then, no, forget it. Right, we'll stop there. Will we? Oh, no. If you want to, you can even write the answer like this. Log A times x plus 2 times 3x plus 2 cubed. If that makes you sad, don't do it. It's for those people who like super simplifying. That's as simplified as I can make it. Because what I've done there, if you want to know how I did that, in my head I just thought of the constant c. Instead of calling it c, I called it log another constant called a. I mean, it just stands for constant, right? So, you know, c is constant. So I can call this constant anything I want. C, A, B, Andy, whatever name. Sorry, so I call this log a. Why do I call it log a? Because that lets me put the two logs together as a multiplication. The first rule of logs. Unnecessary, but you've seen it. Okay? I'll do another example now, so write that one down. You don't need the last line there, okay? So So that is one with a log in it. I'd like to do one with a tan in it now. So that would be, the first tan one would be I here. How did I know? I want to say because I'm super intelligent, but I just looked at the answer at the back. You know, you look at this and then matrix styles, the information just comes to you. Okay, so I'm going to do I now, I think it was. It's a little bit more difficult than this. The reason I'm showing the simplifying, by the way, is because sometimes in the exam they will say, show that this here equals this. In fact, for this topic, it is quite common in the exam that they don't simply say, integrate this. Instead, they would say, integrate this and show that the answer can be written like this. Okay? So, it just means that you have an extra 2 or 3 steps at the end. And often the simplifying comes about by using log rules from semester 1. So remember I said the semester 2 topics do not, the semester 2 exam does not contain semester 1 topics or questions, which is true, but as you can see, like I said also, it will build on the topics from semester 1. What's wrong? Okay, so next question now. Yes, the I one. So with I, we have integrate 6x squared plus 15x plus 45 over minus 3x cubed minus 13x squared minus 28x minus 8 dx. Okay, here you go. Take your calculator there. So, mode 54, and just to be clear, to get mode 54 on your calculator, you press the mode button, followed by 5, followed by 4, which is the number before 5. Did you get that? Good, alright. So you have minus 3, minus 13, minus 28, and minus 8. Now, unfortunately, we can see that when I look at this here, I get only one answer, which means the other answer is a quadratic. The answer that I get is, loading again, minus 1 over 3. So 3x plus 1 is one of the factors. So you can change this into 3x plus 1, but you don't know what the other piece is. But we know how to find it by long division. Yes?
Why didn't do the improper things? Because
This is proper though.
it's proper.
Yeah. Because the power on the top
Yeah,
is...
it's
Yes. 3x plus 1. Divided into minus 3x cubed minus 13x squared minus 28x minus 8. So here I have minus x squared. So that would be minus 3x squared minus x squared. When I subtract, I'd be left with minus 12x squared minus 28x minus 8. Here I have minus 4x minus 12x squared minus 4x all over minus 24x minus 8. So here I need a minus 8 to finish. I get minus 24x minus 8. So that's the quadratic. I can write it in even here. So what I've figured out is that this here can be written as 3x plus 1 times minus x squared minus 4x minus 8. What's wrong, I'm Jared? Yes, it's cut off, is it? Yeah. Notice how I'm saving time by not bothering to do the last multiplication and subtraction, because I can see it'll be 0. Yeah? What's wrong? What? What's wrong? Can I move on now? Now, we know we're going to use proper partial fractions here. So this fraction here, what would that equal? A over 3x plus 1 plus, very good, plus bx plus c over this quadratic. Then what do I do after that? I multiply everything by the denominator. Again, to save time and to speed things up, I'm going to skip a couple of steps and go straight to the part where I have the straight equation with the denominators multiplied. So I'll end up with 6x squared plus 15x plus 45 equals a minus x squared minus 4x minus 8 plus bx plus c times 3x plus 1. That's a 15 there. So that's what you end up with. Okay. Because I don't have the question in front of me, so I want to see the original as well at the same time. That's all. You don't need to do that. You can go down the page as normal. You don't need to go back up the page, okay? Right, now, we could start off with using, so I'm going to go up to here now. Shh. Let me make some space. Okay. I'll start off with x equals minus 1 over 3. Let's see what we get. So, just to help me out here, can you type this in here but put x equal to minus 1 over 3? And then I'll do this one here. So I got equals minus 61 over 9a. Okay, what do we get on the left here? Just exactly 38? Yes? Okay. So now, 38 divided by that, okay, I must have done something wrong here. Minus 1 over 3. Okay. Wait, hang on, hold on. Which one are you telling me?
On the left, it's 192.
This?
Yeah.
So this is wrong.
Yeah.
What is it? Right, that's much better. So now I get a equals minus 6. So I have 6x squared plus 15x plus 45. Now, I know what the a is. It's minus 6. So what I'm going to do now is use the comparison method. So I'm going to put in a is minus 6 and then compare the left and the right. So here I'll have 6x squared and here I'll have 3bx squared. So I get 6a plus 3bx squared plus, here I get 24, and then here I'll get 3c plus b x. And then the constant at the end will be 6 times 8 and then the 3c. So 48 plus c. Squeeze it in there. So So now I compare. Well, the best one to compare is the last one, because I get 45 equals 48 plus C. So C must equal minus 3. Oh, sorry, I wrote A here, but I know what A is. Sorry, A is... wait, there is no A there, because I multiplied it in. Sorry, there's no A there. Scratch that out. Alright, and then I should look at this one next, because this can give me the B. I get 6. That's a minus 6. 6 equals minus 6 plus 3B. So B equals 4. So I got my A, I got my B, and I got my C.
84 plus C, right?
84. You are reading in Arabic. 48 plus C. It's all this Arabic speaking. Okay, so now I have my A, B, and C. I can go back to my question. So I'll just make space here. Amjad, focus. You can play with your bird friends after class, okay? Right, so I know now that this equals A. What was A? Minus 6 over 3x plus 1 dx. And then what was the B and the C? 4x minus 3 over minus x squared, yeah? Minus 4x minus 8 dx. Okay, do you have that so far? That C was 3, was it? Yeah, minus 3. Yeah. Okay. Now, listen. Just to clean up the fraction on the right, I'll multiply the numerator and the denominator by minus 1. Because I don't like all the minuses in the denominator. It would be much easier for me if I put a minus on the top and the bottom. So here I'll get minus 6 over 1 over 3x plus 1 dx. Actually, you know what I'll do? I'll take a minus out. So it'll be minus 4x minus 3 all over x squared minus 4x minus 8 dx. Sorry, of course, thanks, Hong. Plus. Okay. Now, we can't split up the fraction on the right. Why not? Yeah, because we know the quadratic has no solutions. So what could we try to do from our lesson on simple rational functions? We could try to let u equal to the denominator, but I see a potential problem. But we can try if you want, okay? So if I let u equal to the denominator in both, here we let u equal 3x plus 1. This will become minus 6 over 3, 1 over u du, which will equal minus 2 log 3x plus 1 when we do it. Now let's see what happens here. I'll do this one in more detail. U equals x squared plus 4x plus 8. So du dx equals 2x plus 4. Yep. So what does dx equal? Du over 2x plus 4. So now my question becomes minus integrate 4x minus 3 over u times du over 2x plus 4. Now we see a big problem, don't we? What's the big problem? Yeah, it doesn't cancel here, does it? It doesn't cancel. So this approach doesn't work. So now we have to try a different way to do it. So I'm going to remove this here, okay? I mean, you could still write it down in your notebook, that's good, but if you didn't write it down, that's okay, because it's not the method that's going to work. And I wanted to show you the reason why. The reason it doesn't work is because it doesn't cancel the numerator later. You see here? It's because these are different. And this sometimes happens. No, I said you don't have to write it down because it doesn't work. I'm just saying this method doesn't work. So what's our other choices here? What's our other choices? Huh? No. Let's see what happens if I complete the square. So this would be x plus 2 squared minus 8. Yeah, no, sorry. Plus, this would be plus 4. So, yeah, why is that there? Anyway. So what I did there was complete the square. Okay. Now I could try u equal to what? Do you remember what to do for this? Square root x plus 2 squared over 4. Isn't that it? The first over the second. So that would be x plus 2 over 2. Or if you prefer, you're letting u equal a half x plus 1 when you divide it. So what does du dx equal? Well, du dx, that equals a half. So I get then dx equals 2 du. So I go back now to this line here and put that result in. So now I have 4x minus 3 over, this will, I think this always ends up being u squared plus 2. Is that right? Yeah, if I get here, what you need to do is get the x here. So what does x equal here? I have to get the x. U minus 1 times 2, that equals x from this line here. You see what I did? I brought the 1 over here and then multiplied by 2. So if I put that in here, this will become 4u squared plus 4. Yeah, so the 4 comes out. After subbing it in, you'd be left with u squared plus 1. And dx is 2 du. So 2 du. What, Andy?
Is it 2u minus 2 equals x?
Yeah. It came from this line. Sorry, it's not clear. It came from that one. And then I took this one here and I put that back into that. Now, this will be a half 4x minus 3 over u squared plus 1 du. Which looks difficult, but it's not so bad because you have an easy way to change this. Remember, here x equals 2u minus 2. So what would 4x equal? If I multiply this by 4, what do I get? 8u minus 8. So 8u minus 8 minus 3 over u squared plus 1 du. Equals a half 8u minus 11 over u squared plus 1 du. Nearly there, guys, nearly there. Now, can we do this one? No. Because remember, for the tan inverse formula, what do you need? 1 over u squared or x squared plus 1. Isn't it? Yeah. But it's not too far away from that. In fact, if you separate this into 2 fractions, it becomes more doable. So I'll split this up into 2 now. So the first one will be a half 8u over u squared plus 1 minus 11 over 2 1 over u squared plus 1 du. I'm splitting this up into 2, okay, so the half is still in front of both. So this half here is because of this, and this gets split into 2. So that's why the 11 and the 2 is there. Equals, well, a half goes into 8 4 times, so it's 4 integrate u over u squared plus 1 du minus 11 over 2. I'm not really doing anything here on this line, actually. Now, this is great because we know what this one here is. What's this one? Tan inverse, isn't it? So this will be 11 over 2 tan inverse u. And what was u? No, it was x. Oh, hang on, where's it gone? A half x plus 1. A half x plus 1. Now this one here, I can solve this one with a substitution. What substitution will I need here? V equals u squared plus 1. When you use this substitution in here, this will simplify to 2 1 over v dv. And we know what this one here is. What's this one going to be? What's 1 over v dv? Log v. So that equals 2 log v. But what's v? U squared plus 1. But what's u? A half x plus 1 squared plus 1 minus 11 over 2 tan inverse a half x plus 1. Yeah. Yes. You just wait until the next one, which is integrating improper partial fractions. Yes?
Can you chance that this will appear on section A? Pretty good.
Yeah, actually, you're right. That's a good point, Anja. No, this is only section B. Now, that's the answer. But if you recall, that was the answer for the second half previously. So if I go back up. What? Yeah, plus 1 here. No, there's no more calculation to do. I just need to put this answer back at the top. I'll go back here, don't worry. I'll go back down, don't worry. If I go back up here, remember what I did. Listen, what I did was this piece here. Remember? I already had this piece done. Okay? So if I want the full answer, I must not forget to write this at the bottom as well. Minus 2 log 3x plus 1. So down here at the end, what was I saying? Minus 2 log 3x plus 1. Was it a plus or a minus originally? It was a minus actually. So minus and minus, so plus there. Yeah, there's an equal here, equal to this. Let me write that again, but a bit smaller. This is the final answer. Oh, of course, I forgot my plus C. There you go. Now it's correct. Question, Andy?
You have a u here, how to make it?
E equals u squared plus 1. I promise you will simplify. I'll try it. No, but try it. Just do it. Just let me start. Just do it. I promise you will simplify. Yes. I replaced the x here by using this formula. That became that. This x here was replaced by using this formula. And that's how it became that. It replaced x by using this formula. Now, okay. What you'll notice though with my final answer is if I wanted to, I could put those logs together, of course, because you see they're both minuses, right? Minus 2's. So those 2's, what can I do with them? They could go up to the power. I could take the minus out in front, and when I add logs together, what rule is that? If log A plus log B? Log A plus B, isn't it? So, if the question asked you to simplify it into a certain form, the only simplifying that you could do here, which I'll do in red, is bring the 2 up here, take the minus out, and make that a plus, and then this will equal minus log 3x plus 1 squared, bracket a half x plus 1 squared plus 1 squared, and then plus the tan piece, etc. Or just etc. And yes, Andy, you could take 2 squares out and put bigger bracket squared.
Skip the very breakfast step.
What final step? Yeah, but I think that's going to happen. But I told you to trust me that if E equals that, it will simplify. Yes? Right. I do want you to stick around for a couple of minutes to have a start on these, okay? So, let me have a look here. Number 2 is very, very simple. No, actually K. K is the shortest one there. It's like my first example. It won't take you too long to do. So I'd like you to try the K first. Yeah. If you didn't know the chapter simple rational. If you were in class, I wrote what I'm saying is you could rewrite your answer. There's many different ways to write your answer. Don't worry about it.
Which one is
Define that. Don't worry, I have to check when I go This is not a story about later. Yes, of course. But,
In the exam, will
Yes.
you be asked to write it in the simplest form?
somebody